everybody. If you are watching this, you are in my Dolphins Math group. You might have been unable to participate in the live session at 11:30, and that's okay. We're actually going to do a little bit of some multiplication, multi-digit multiplication, and some word problems that are multi-step. Those are the things that we were working on before we got out on break. I'm going to go ahead and review with you right now how to do the problem 67 times 28 using the area model first, and that's the method my fourth graders are using. And then for my fifth graders, we'll look at how to solve this using the standard algorithm. I'm actually going to turn this light on, so this will be a little brighter. So let's go ahead and start with this. When we do the area model and we're just working on computation, that's just solving these number problems, we want to remember we're breaking up the factors. And my factors are the numbers I'm multiplying together. So 67 is one factor and 28 is another. So with this problem, I'm going to break up 67 and 28 into expanded form. So what is the value of those numbers based on the place value they're in? So the 7 is in the ones, and I have 6 tens since my 6 is in the tens place. So the first thing I'm going to do is I'm going to draw my area model box. So a 7 in the ones would be worth 7, and a 6 in the tens would be worth 60. Now remember where I have my plus sign, I kind of just extend that line. Now with 28, I have an 8 in the ones, so that's only worth 8. And 2 tens would be worth 20. And again, I just extend where I have that plus sign. Now in each section of this, I want to go ahead and write the multiplication problem that I'm going to solve. So here I'm doing 20 times 60, 20 times 7, 8 times 60, and 8 times 7. Now I'm going to solve those problems with just the basic fact. So I'm going to say, okay, well, what is 2 times 6? And that's 12. And how many zeros are in that box? 2. So I add 2 to that box. So 20 times 60 is 1,200. Then I say, okay, 2 times 7 is 14. How many zeros were in that box? 1. I add my 0. 20 times 7 would equal 140. So I found the product for the first two multiplication problems. Now I'm looking for the product for the bottom two. Remember, product is just my answer to my multiplication problem. So 8 times 6, and this is where if you're doing extra math at home, hopefully you're building that multiplication fluency so that you're learning those facts. 8 times 6 is 48. How many zeros in the box? 1, so I just add 1. And 8 times 7 is 56. There's no zeros here, so I don't have to add another 0. Now I'm taking these numbers and I'm coming to the side and I'm going to add all those partial products up to find the whole part, or the whole product, the whole answer to my multiplication problem. Okay, so I'll start in the ones and I'll add all the way down. And 0 plus 0 plus 0 plus 6 is 6. 8 plus 4 plus 5. Well, I know 5 and 4 makes 9. 9 plus 8 more is 17. I carry my 1. 2 plus 1 is 3. Plus 1 more is 4. 4 plus 4 is 8. And here I'm just bringing down the 1. So it's telling me that in 67 times 28, my product should be 1,876. Okay, so what I would like to do now is I'm going to show us how to solve this problem using my standard algorithm, which is for my fifth graders. So fourth graders, if you want, you can fast forward for this next part. So fifth graders, when we do the standard algorithm, we still should get the same product. So with the standard algorithm, I'm starting here in this ones, and I'm multiplying everything in the ones. So 8 times 7 is 56. And I carry the 5 here. Because really what I'm doing is I'm starting first with the 8 and doing 67 times 8. 7 times 8, 6 times 8. Then I'll come here and do 67 times 2 and put those two together. So now 8 times 6 is 48. So 48, I'm just adding 5 more. 49, 50, 51, 52, 53. Now I'm done with the 0 here in the 1, so I'm going to mark it out, and then I put a 0 there as a placeholder for where that 8 was. And now I'm going to do the 2, and I'm going to multiply it times the 7. So 2 times 7 is 14. And I now have a 1 here. So what I like to do is I just cross this out and put the new number that I'm carrying. Oops, you can't see that too well. So what I did was I crossed out the 5 that was here and put the 1 from the 2 times 7, which was 14. So 4 here, 1 up top. And then 6 times 2 is 12, plus 1 more is 13. Now I can add these two together, and we should get the same product. 6 plus 0 is 6, 3 plus 4 is 7, 5 plus 3 is 8, and I drop down the 1. So with both methods, we're still getting the same product. I'm going to give you guys a second. I'm going to put a problem up here, and I'd like for you to try to solve that problem on your own using that method, okay? So you're either going to use area or standard algorithm. So let's just do a 3-digit. Do the same process, okay? 3-digit by a 1-digit. I'll help you set up your area model. So 752, the value of the 2 and the 1s is a 2. The value of 5 tens is 50. And 7 in the hundreds is worth 700. And then I'm multiplying it by 2 1s. Now my 5th grade, you can go ahead, do your standard algorithm. So pause the video, work it out, then unpause and come back and we'll check it together. So at this point, you should have had some time to pause, work your problem out, and check it. I'm going to really quickly go over it to see if we got the correct product together. If you make a mistake, fix your error. And then if you have any questions, feel free to join the live sessions to ask or drop on Fridays for your office hour times if you're still having a hard time. So here I'll start with 2 times 700, 2 times 50, and then 2 times 2. So I know 2 times 2 is 4, 2 times 5 is 10, and there was 1 0 in that box, so I need to add another 0 to my product. 2 times 7 is 14. There were 2 zeros, so I should add those 2 zeros up. Now I take those partial products and I add them over here to the side. So I'll come down. 0 plus 0 plus 4 is 4. 0 plus 0. 4 plus 1 is 5. Drop the 1. Now I'm going to come up here because it's telling me my product is 1,504. Let's check with the standard algorithm. So I'm going to just erase this top part and let's make sure my 5th graders got the same answer. 2 times 2 is 4. 2 times 5 is 10. And I'm putting my 0 and I'm carrying over my 1. 7 times 2 is 14, plus 1 more is 15. So I still get 1,504 the way I did down here. So what I'm going to do now is I'm going to flip this board over. And I have a multi-step word problem here on the back. Move it so that you can see everything. Let me close this. There we go. So I have a problem about a hummingbird. A hummingbird has a resting heart rate of 250 beats per minute. How many beats will 2 birds have together after resting for 6 minutes? We're going to talk a little bit about the problem, break it down a little bit, and then I want you guys to try to draw a visual that can go along with this problem and kind of go along each sentence to build that picture of what's happening. And then I'm going to give you some time to try to solve it. But let's first break it down together. So it says a hummingbird has a resting heart rate of 250 beats per minute. So all that means is if a hummingbird isn't flying, it's just relaxing, maybe it's sleeping, its heart rate is going 250 beats per minute. So I'm going to stop for a minute and I want you to think about what is a visual I could possibly draw to show that bird with 250 beats per minute for its heart rate. Now it wants to know how many beats will 2 birds have together. after resting for 6 minutes. So in this problem, I have not just one, that's my bird, but 2 birds. I want you to take a minute and see if you can maybe add to my picture. Think about what it's telling me. Well, he has 250 beats per minute, and well, so does this bird. How can I start to add that to my picture? And then if I pay attention, it wants to know, though, how many beats will they both have after resting for 6 minutes? Pause it, give it a second, try to solve it as best as you can, and then come back and I'll help you out if you still need some help. So at this point, you should have had some time to try to work out the problem on your own. So I'm going to go through it with you and kind of show you how I would have done my picture. So a hummingbird has a resting heart rate of 250 beats per minute. How many beats will 2 birds have after resting together for 6 minutes? So I have my 2 birds here already drawn. This bird has 250 beats per minute when it's resting. And then so does this bird. And this is in 1 minute. This is in 1 minute. So just in 1 minute, these 2 birds together would have 250 plus 250. Or I can use multiplication and do 250 times 2. So for that, let's go ahead and let's use my area method. So 250 times 2. Let's first solve it with our area model. So the value of 250, that 0 in the ones is worth 0. 5 tens is 50, plus 200 is worth 200. So 200 plus 50 plus 0. And I'm multiplying it times 2, so I put the 2 out here. 2 times 200, 2 times 50, and then 2 times 0, which is easy. That's just 0. 2 times 5 is 10. I add my 1 extra 0. 2 times 2 is 4, and there's 2 zeros in that box, so I need to add 2 more. So now I can come over here and I can add those partial products. 400 plus 100 is 500. So just in 1 minute, those 2 hummingbirds have 500 beats. Now I'm going to continue that pattern, and I'm going to be counting by 500. So I can continually add 500. 500 plus 500 would be 1,002 minutes. But I'm going to use multiplication because really what I'm doing is 500 times, I want to know in 6 minutes. So I'm going to do 500 times 6. And for that one, I'm going to do the standard algorithm since we just did area model. 0 times 0 is 0. 0 times 0 is 0. And 5 times 6 is 30. So in 6 minutes, they would have had 3,000 beats together. So guys, I'm going to post some stuff to Dojo that you can do for extra practice. The stuff that's posted to Dojo is completely optional. If you can, you meet me again live next week. If not, be working on the stuff that you should have gotten in your packet. Maybe do 1 item a week, work on a little bit of extra math. If not, I will see you later. Have a good afternoon.